Hi, my name is Messica, and I'm a PhD student at the Ben Gurion University. The topic of my PhD is incorporating price in a recommender system. And what I will talk about today is how we can use, we heard a little bit already today about LSTM and RNN, and of course all the embedding and deep learning revolution, and we will see how we can use it for a recommender system. So one of the problems with e-commerce recommendation is called session-based recommendation. And session-based recommendation is a scenario where we have a new user coming to the website, which we don't have any history about it. No transactional history, no any kind of history. And this is actually a very common scenario in e-commerce, because many of the users are coming through a promotion, different kind of promotions, and they come to see one product. And we want to keep them in the website, in our e-commerce site. And moreover, as Efrat said earlier, we want to make a conversion. We want to offer him all the relevant products that might be relevant for him, but we don't have any history about him. We only have few clicks or some queries that he already did during this session. So this is the problem. And until the deep learning revolution, the most common algorithm to solve this problem was the item-to-item recommendation. So we saw which products the user clicked on, and then we used the history of which product were bought with this the product that he clicked, and based on that, we give recommendation to the user. But with the deep learning, we can do more than that. And the inspiration for this approach is actually came from NLP, natural language processing, where we see that by using the word embedding, and you're probably familiar with the word2vec and the glove algorithms. So by using word embedding, you can take into account not only the products which are bought together, but also the order of the clicks. So this gives us an additional information, and this led us to the idea of using RNN and LSTM in order to predict which product might be interesting for the user. So this is the problem. And the approach is similarly to the natural language processing. What we do is we represent each product by one hot vector. So each product is like a word, and the session, like the journey of the user within the e-commerce website, is like a document. So we represent a product by one hot vector. A session is actually a sequence of product clicks, and it's like a sequence of words in the NLP. And what we want to do is to predict what will be the next product that the user will click. And this is similar to NLP. What will be the next word that the user will type, and stuff like that. We published a paper last year. We gave the reference here. Actually, there are some nice visuals here that you can look at if you want to look at more. Okay, so here we just I just clarify what does it mean one hot representation. So the size of the vector is actually the number of the products that we have in the catalog. And each product has a bit in this vector. So what we need to do is we need to take our catalog, the product ID, and actually map every product into an ID. And in this way, we represent each product by one vector. Now what we do is we take a sequence of the clicks where every product is a vector and the session is actually a matrix. And we add it into a neural network. The first layer is an embedding layer, which actually provide a kind of semantic representation of each product by similar sessions. Here we tested different architecture, either to use the embedding integrated into the prediction network or to use it as a standalone. In both cases, we got nice results. What we show in the paper, and it's actually very interesting, is that the embedding is really meaningful. So like if you look at what is the closest product to iPhone 5, for example, so you can see it's iPhone 6. Or if you want to look at different relations, like what's the relation between iPhone 5 to iPhone 6, what will be what will be the same relation for Samsung 5, so we will get Samsung 6. All of it is history now, right, with the iPhone X and everything. But at the time, it was a very nice product. So anyway, we take the matrix, we add one layer of embedding. The second layer is actually the RNN, which detects the sequence of the clicks and not only the products that were involved in the session. And in the last layer, we predict what will be the next click, and we also have one hot vector. So this is the network architecture. One of the challenges, of course, is to find the right architecture for the model, and we will talk about some best practices in the next slide. And as was already mentioned, for deep learning, we need a lot of data. And we were very lucky to work here with a large European department store who gave us really a lot of data. So if we're looking a little bit at the best practices, so we filter out some rare products, because we don't have any meaningful information for them. A ratio of 300, this is very similar to NLP, is a quite good embedding size to start from. SGD optimizer is a good choice in cases you don't have, like you have the relation between the number of parameters and the number of instances is lower than 10. SGD will be a good choice. And you can leverage a lot of NLP examples online with Keras, with TensorFlow, in order to implement this kind of e-commerce models. Okay, so now let me convince you that it's worthwhile doing all this work. So what we see here is the recall at K, which means like we want to see if we give one recommendation, two recommendations, three recommendations, we want to see how many of the products that we recommended to the consumer, he really consumed. And what you see here is the bunch of methods that are used for this task. So we see like the item to item, which was the best algorithm before the deep learning. Item popularity, which is of course a very naive solution, and SVD, which is a very good solution, but you need a user history for that. And the green lines are the RNN, the GRU actually in this case, and the blue ones are the ANN. So it's not RNN, which takes into account the order of the clicks, but only ANN, which takes into account the products that were clicked. And you can see that the deep learning methods are really outperform the traditional, and really they are significantly better. However, the RNN, which is from a computational point of view, it's much more heavier. It's a little bit better than the ANN, but not significantly. There is also a table here that you can look not only on the recall, but also on the precision and some other measurement, and you will see that really the deep learning is much better than traditional methods for this type of session-based recommendation. Thank you, and if you have any questions, I will be glad to answer.